Hey everyone! I know it's been a while since I've done a heart-to-heart tutoring service video. I've been off the last couple of semesters doing work for the GED Testing Service Board of Directors. Now I'm back and I just began a fall term for Prince George's Community College. So this new set of videos that you will see pop up are for my new set of students. And this means that the course material for the class has started over. So we're starting back to the basic math. I designed these videos for my new set of students. If you're not a student in my class and you're still watching my series of videos, I'm still hoping that you'll find the videos useful. So for this video, I'm going to start with rounding decimals and going into integers. If you're looking for other GED concepts like in algebra and geometry skills, feel free to scroll through my channel and look at previous videos I've done, for the past couple of years, and you'll probably find some information there that could also help you out. But for this video, we are working on naming decimals and then going on to integers. So the first thing that we did in class was we talked about the assessment that we had. And so, so when we did our introductions with each other and we kind of did a little bit of assessment and, was trying to brush off the dust of our skills in math. And everybody was just a little bit nervous about those questions, especially because you couldn't use a calculator. And everybody expressed concerns about doing those fraction questions, without a calculator. But guess what? I noticed a pattern. I noticed a pattern that everybody got one question wrong. There was one question in which everybody got wrong, and it surprised me. And when I discussed this in class, remember, everyone thought perhaps it was the fraction question that everybody got wrong, but that was not it. Remember that one question that everybody got wrong was a rounding question. Why is this so important to review? Remember, I'm not saying you don't know how to round, but perhaps you had forgotten how to round. Or perhaps you didn't truly fully understand the rules of rounding. But why is this so important? Because you will get lots of GED word problems that will ask you to round to the nearest whole number, round to the nearest tenth, round to the nearest hundredth, like it says in here. And if you don't round your answer correctly, you could get an answer wrong by a simple mistake. So it was very good for us to review rounding. So this is where we're going to start. And when we do the rounding, we had to first review a place value chart. So I gave you a place value chart. Here it is. Remember this? So before we even begin understanding the rules of rounding, we must understand a place value chart. So here's my decimal, right? Everything before the decimal is a whole number. Ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, okay? And so, most of us understand, ones, tens, hundreds, thousands, 10,000s, 100,000s. We might struggle with what comes next after that. Let's take a look at after the decimal. Tenths, notice the THS ending. Hundreds, thousands, 10,000s, hundreds thousands, millionths, okay? So if you see a THS ending, you know that represents a number after the decimal. Hey, here's another thing too, right? There is a pattern. Notice it's a repeating pattern, right? Except after the decimal, you don't have a ones place, like a whole number ones. You don't have a ones place. It just starts with tenths. Okay, so you can see the pattern. Then everything else repeats except you have a THS ending. So if you come across the word with a THS ending, see that? You know you're talking about the number that's after the decimal, the nearest hundredths place. So what number is in the hundredths place when it comes to this? Look at that. Here's tenths, because remember it doesn't start with ones. Here's hundredths. That 7 is in the hundredths place. There it is on our chart too. Take a look. See that? 7 is in the hundredths place. So how to round that? How to round 5.27 to the hundredths place? I'm going to show you where everybody made the mistake. But before we begin that, let's first take a look and practice understanding place value with names. So if I were to ask you this, like question number 1. Question number 1, we have 725, right? What place value is that 5? What place value is that 5? Notice there is no decimal here. There's no decimal. So that's 725 as a whole number. So I could take a look at my place value chart right here, and I would put 725 before the decimal because it is a whole number. So I have 725. And then it asks me, let's go back, taking a look at the 5. What place value is that 5? Guess what? You said it correctly. It's in the ones place. So making sure you understand the place value chart. Again, it is a good idea to make sure you have these memorized. Always a good idea. Let's take a look at the next one. Number 2, what place value is the 3? This number is 7,823. Taking a look at my place value chart, this time I'm going to put in 7,823. 7,000, look, I'm already saying the word thousand, so I know I'm going to start here, right? 7,800, see the 100, and 20 tens, 3 ones. 7,823, right? And so it's asking me for what place value is the 3. Look again, it's in the ones place. Let's see if we can find something different. Now this is a good one. Take a look at number 4. Look at that number, okay? If we have our place chart value memorized, it becomes easier to recognize what number is in what place. So let me first show you by counting. Check this out. Now I noticed that all these numbers are before a decimal. Why? Because there's no decimal in this answer or this question right here, okay? So I know what I can do is this. I'm going to count. 1, 2, 3, 4, 5. All right, this is 5 places in front of the decimal. So I can count this way, count 5 places before the decimal. 1, 2, 3, 4, 5. I landed right here. That number is in a 10,000th place. So here, that number 1 is in a 10,000th place. If I have it memorized, I'm simply going through my head, ones, tens, hundreds, thousands, 10,000s. Let's take a look at another. All right, so taking a look at number 5 next, and notice I've turned off my camera as I resume this recording. I figure you know what I look like by now, right? So taking a look at number 5. So now we're going to start trying to do this from memory. So that means trying to memorize the place value chart. Okay, so number 5, sorry, let me go back to here. Number 5 is a whole number. There's no decimal number. So again, from memory, starting with the whole numbers, the order goes ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions. All right, here we go. So we're looking at the 4. So starting from the 6, ones, tens, hundreds. 4's in the hundreds place. There we go. And then let's go look at numbers 6. We're looking at the 5. Again, it is a whole number, so starting with ones, tens, hundreds, thousands, 10,000s. That 5 is in the 10,000s place because it comes 1, 2, 3, 4. It is the 5th number before the decimal. 1, 2, 3, 4, 5. It is the 5th number before the decimal. It is right here in the 10,000s place. Let's keep going. Number 7. Ones, tens, hundreds, thousands. Number 7 is thousands place. Number 8, ones, tens place. Now, number 9 is our first number that begins with a decimal. So let's take a look at the decimal place value, okay? So the numbers that come after the decimal. So now we're over here. Remember, it doesn't start with ones like it does before the decimal. It starts with tens. Don't forget the THS ending. So whenever you see a THS ending, you know we're talking about numbers that are after the decimal. After the decimal. Tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. Okay? So taking a look at our sheet right here, looking at number 9, it is 1, 2, 3, 4 places after the decimal. So if I go back, I'm taking a look at 1, 2, 3, 4 places after the decimal. For number 9, I'm in a 10,000ths place. 10,000ths place. Number 10. From memory, tenths, hundreds, thousandths. Number 11. Tenths, hundredths. Number 15. Tenths, hundreds, thousands, 10,000ths place. So there it is, my friends. We're taking a look at a place value and the names of the place value situation. Again, it's very important to try to have the place value chart memorized. And therefore, when you have questions that ask you, hey, round this number to the nearest whichever, it'll be easier to understand. So speaking of rounding which number to the nearest whichever, let's go back to that question that we had, right? The question that we had said, round this number to the nearest hundredths place. And that number was 5.275. Let me go ahead and put that back over here in our chart. So the number that that we had on that little assessment was 5.275. Okay. And the question was round to the nearest hundredths place. Okay. Round to the nearest hundredths place. Now, I saw a lot of possible different answers right here. And I'm thinking, okay, we just need to review and, dust off your shoulders a little bit and bring your memory back on how to do that rounding. Do you remember that 5 and up rule? Does that sound familiar to you? And we were taught in school that we know to round up if the following digit is 5 or above. Let me show you what I'm meaning. So if we're rounding to the nearest hundredths place, we first have to find the digit that's in the hundredths place. 7 is in the hundredths place, right? So this is where we're looking. We're looking at the 7 right here. However, it is the number that's next to it that tells us what to do with that 7. The number next to the 7 is 5, right? So that 5 is going to tell us what to do with the 7. So that 7 go up or so that 7 stay the same, right? And so if it's the 5 or above rule, remember that if the number is 5 or above, that 5 is telling the number next to it to go up. So that 7 actually rounded to the nearest hundredths is going to turn into an 8. So the correct answer for this one was 5.28. There it is. 5.275 rounded to the nearest hundredths place is 5.28. So we're going to put that into practice now by taking a look of different place values in which we're going to practice to round. Okay, so here we go. And we're going to practice here rounding at different place values. Again, what's the importance? Why is it so important? Rounding seems such like an easy thing to do. Sometimes it is and sometimes it isn't. But why is it so important for you as you're studying your GED? There are lots of questions, algebra questions, geometry questions, etc., regular basic skills questions, especially in word problems that'll ask you to round your answer. It'll say round to the nearest whole number, round to the nearest tenth, round to the nearest hundredth. And you could easily get a question wrong simply because you round it wrong. And you did all that work. Imagine yourself doing all that work on a hard algebra question and you chose the wrong rounded answer. So this is why we want to make sure we dust off on these skills and make sure we know what we're doing. So for our first set right here, we're going to practice rounding each decimal to the nearest whole number. Now, rounding to the nearest whole number. So that means that we take a look at the first number after the decimal to figure out if the whole number is going to round up. Okay? Now, so we have 32.6. Now, we see that the 6, right? See that? It's bigger than 5. So it's bigger than 5. That means that whole number is going to round up. So that 32.6 is going to round up to 33. Let's go over to letter B. This time I have 66.21. Okay? See that? 2 lower than 5. It's lower than 5. What do? Well, we drop it off. That's like the rounding down thing. We drop it off. So 66.21 actually will just round down to just 66. Or I like to call it rounding off, right? The letter C, let's take a look at that one. We have 53.93. 53.93, we can see that the number after the decimal is a 9. So that's going to force the 3 to round up. And so the whole number it's going to round to is 54. Then we have 17.2. You got it. That 2 is not bigger than 5. So we're going to round down or round off, leaving the whole number as just 17. Now let's get to place value with the decimals. So this set right here says we're going to round to the nearest tenth. Okay. So remember with our chart, rounding to the nearest tenth. There we go. Tenths place is the first number after the decimal. So I take a look at the first number after the decimal, but it's the hundredths place that's going to tell me what to do. Let me demonstrate. So for number 2, if I'm rounding to the nearest tenth, I have 71.841. All right, so I'm going to take a look. My number 8, see, that is in the tenths place, but it's the 4 that's going to tell me what to do with the 8. The 4 is not larger than 5. So what am I going to do? I'm going to end up rounding down, or rounding off as I like to call it. So this is going to round off to 71.8. Leave the rest of it off because that 4 was not higher than 5. Okay? And if I'm rounding to the nearest tenth, we got to keep in mind that means I need to have one number here. I need to have at least one number here for the place value to match what it's asking for. Let me demonstrate again so you can start seeing the pattern. Looking at letter B. All right. So letter B, we have 45.47. 4 is in the tenths place. We look next to it, we see the 7. Okay? That 7 is larger than 5. So that 7 is going to tell us to change that 4 into a 5. So I have 45.5. There you go. And I know I rounded to the nearest tenths place because I have one number after the decimal, which represents the tenths place. Let's keep it going. So now letter C, I have 20.36. Okay. So I see the 3 is in my tenths place, but I see the 6 is next to it. That 6 is telling me to do what with that 3? You got it. Turn it to a 4. So for this one, it's going to round up to 20.4. And letter D, I have 82.713. Again, I am just rounding to the nearest tenths place. I see the 7 in my tenths place, but then I see a 1 right next to it. So what do? Okay, what I'm going to do is round off to the 7, and that 1 is not higher than 5, so I'm going to leave it as 82.7. Because that 1 is not higher than 5, I'm going to round down, or like I said, I like to call it just rounding off, dropping everything else out of it. Let's take a look at our next set. Our next set right here. This time, we're going to round to the nearest hundredth place. Remember, the hundredth place is 2 places after the decimal. Let's give that a practice. All right, so for my first number, I have 52.3589. Okay, so first identify the number that's in the hundredths place. That 3 is in the tenths, that 5 is in the hundredths place. So I am taking a look at the 8 to tell me what to do with that 5, right? So that 8 is telling that 5 to round up because it's larger than 5, right? So if I round up, I'm going to have 52.36, leaving the rest of it off. So I rounded that up to 52.36. Taking a look at letter B. So to the hundredths place, what number is in the hundredths place? You see the 1, right? Now take a look at the 4. What is that 4 telling us what to do? 4 is telling us that we are not going to round up because that 4 is not bigger than 5, is it? So I'm going to put 73.41, right? Why am I leaving the 1 there, right? And dropping off the 4 and everything else? Because it's asking us to round to the hundredths place. So that means I must have 2 places represented after the decimal. Just like when we were representing the tenths place, we had to have 1 place still there after the decimal. So when it says round to the nearest hundredth place, you have to have 2 places after the decimal. Whether you're dropping off or if you're rounding up, you still have to make sure you have 2 places after the decimal when you're doing the hundredths place. It was the same thing that we were doing when we had the 5.725, wasn't it? Round 5.2, I think it was 75 or whichever, and we rounded that up to 5.28. We still had 2 places after the decimal because it said round to the hundredths place. Let's keep it going. All right, let's look at letter C. Letter C. Rounding to the nearest hundredths place, I see my 4 is in the hundredths place, but I'm taking a look at the 3. So if I'm taking a look at the 3, that 3 is telling 4 to do what? Stay the same. Stay the same, okay? Because it's not bigger than 5. So basically, stay the same. So my answer is 87.54. Dropping everything off. Dropping everything off, okay? Looking at letter D, giving that one a try, and we see that there's 2 in the hundredths place. That 9 is telling us to do something. You see that 9 is telling that 2 to go up to 3, isn't it? So my answer is 19.13. That 9 told the 2 to round up. And I represented it by still making sure I had 2 places after the decimal representing the hundredths place. Here we go with some more. This time, let's do round to the thousandths place. Okay. Remember, the thousandths place is the 3rd place after the decimal. The thousandths place is the 3rd place after the decimal, right here. Okay. So, what numbers in a thousandths place for our letter A? We have tenths, hundredths, thousandths, that 9 right there. But it's the 3 that's going to tell us what to do, isn't it? Well, yes, it is. That 3 is not bigger than 5. So that 3 is saying, hey, number 9, stay the same. Drop everything else off. All right, 21.789. Because that 3 was not bigger than 5. And you must have 3 digits after your decimal because it represents the thousandths place. So you must have the 3 digits after the decimal. Let's go to letter B. All right. What numbers in the hundredths place? Tens, hundreds, or excuse me, what's numbers in a thousandths place? Thousandths. The 6 is in a thousandths place. But I'm looking at the 8. That 8 is going to tell me what to do. I see that 8 is bigger than 5, so it's telling that 6 to go up to 7. So my answer would be 94.597. Leave everything else off. Still representing the thousandths place because I have 3 digits right here. Letter C. What digit is in the hundredths, thousandths place? Tens, hundreds, thousands. I see a number 3, and I have a 6. You know now that that 6 is telling that 3 to go up to number 4, right? So 49.464. Last one, letter D. Tens, hundreds, thousands. I see a 5. I see a 5 in the thousandths place, but I see a 4 telling that 5 to stay the same. So I have 7.345. Staying the same. Sorry about the sloppy handwriting, guys. All right, let's try another page. Again, starting with rounding to the nearest whole number. I have 76.4. All right, so I'm taking a look at the decimal. That decimal is going to tell me what to do with the 6. So that the 4 is not higher than 5, so that means I'm going to round down or round off. So that 76.4 is actually just going to remain as 76. Taking a look at letter B. This time I have 43.67. Okay. Now, even though, there's 2 numbers after the decimal, but you really just need to look at the first number here. Okay. So I'm looking at that 6. That 6 is going to tell me what to do with the 3. Okay. 6 is higher than 5, so I'm going to round this to 44. Taking a look at letter C, I have 21.8. Now, I just have a 1 right here, not bigger than 5. So that 1 is saying to this 8, hey, stay the same. So this will just be rounded down or rounded off to 28. Taking a look at letter D, this time I have a 7. Remember, you only have to take a look at the first number after the decimal. That 7 is larger than 5. So it's telling that 4 to round up. So that's going to round up to 95. And again, just dropping off everything else. Let's go back down and practice with the tens place again. All right, here we go. So my first number, 13.37. The 3 is in the tens place. You look at the 7 to see what it's telling the 3 what to do, right? So that 7 you see is bigger than 5. So that 7 is going to say to the 3, hey, you need to round up. Okay? So that 3 turns to a 4. So 13.4. Let's take a look at letter B. Now, to the tens place, I see my 1 is in a tens place, but I need to take a look at the 4. That 4 is telling the 1 what to do. The 4 is not higher than 5. So that 4 is saying, you know what? You need to round down or round off, which means keep my 69, keep my 1, keep it the same, and just drop everything else back off. Again, keeping 1 digit after the decimal because we are rounding to the 10th place. Taking a look at letter C. Here we go. I have a 6 in a 10th place, but it's the 4 telling that 6 what to do. That 4 is not bigger than 5, so that 4 is telling the 6, stay the same, round off. So I have 48.6, rounding off everything else, leaving 1 digit after the decimal to represent the 10th place. Last one. I have 23.478. 4 is in the tens place. That 7 is going to tell the 4 what to do. That 7 is higher than 5. So that 7 is saying to the 4, round up. So it's going to round to 23.5, dropping off everything else, just leaving one digit to represent the tens place. All right, I think we're getting the hang of it. Let's take a look at the hundredths place. All right, so let's take a look for the hundredths place. So remember, the hundredths place is two numbers after the decimal. So for our first one, letter A, the number in the hundredths place is this 1. But we look at this one to tell this one what to do. That sounded kind of funny, didn't it? Okay, so that one is not bigger than 5, so it's telling the one that's in the hundredths place to stay the same. So we're going to round down or round off, as I like to say. So our answer here is 9.71. Again, why 9.71? It's because this one is telling the one that's in the hundredths place what to do. The circle one is not bigger than 5. So it's not bigger than 5. We round down or round off is how I like to put it. So meaning that it will stay the same. So we leave it off at 0.71. Why two numbers after the decimal place? Because we were talking about the hundredths place, which means we need to represent two numbers after the decimal. Let's try another. Here we go. This time, looking at letter B, we have 55.229. The number that's in the hundredths place is this 2. So it's the 9 that's going to tell that 2 what to do. So if I'm going to round up on this one, because that 9 is bigger than 5, I'm going to round it to 55.23. So that 2 that's in the hundredths place will round up to 3, dropping off that 9. Again, has to stay with 2 digits after the decimal, representing the hundredths place, which has 2 digits after the decimal. Looking at letter C, 18.667, this 6 is in the hundredths place. The 7 is going to tell that 6 what to do. That 7 is bigger than 5, so we are going to round up. We round up, we have 18.67. Letter D, we're getting the hang of it here. 4 is in the hundredths place. That 2 is going to tell the 4 what to do. So I will round to 72.94. Rounding down, or I like to call it rounding off, because you're not really going down. You're just dropping everything else off. Okay. All right, now we go to the thousandths place. Okay, for letter A, tens, hundreds, thousands. That 0 is in the thousandths place, right? That 0 is in its thousandths place. That 6 is going to tell the 0 what to do. 6 is bigger than 5, so that 6 is telling 0, hey, round up to 1. So my answer, 37.591. 3 numbers have to be present after the decimal because we are representing the thousandths place. Again, 3 numbers after the decimal this time, because we are repping the tens, hundreds, thousandths place. Let's continue. Looking at letter B. The tens, hundreds, thousandths place. This 8 is in the thousandths place, so we take a look at the 9. We can see that 9 is telling that 8 to round up. So that 8 is going to round up to a 9. So I have 23.139. Letter C. 4 is in the hundredths place. That 1 is telling that 4, you know what? Stay where you are. Stay the same. Round out. Round off. 62.754. And for our last one, the 6 is in the hundredths place. That 3 is telling it what to do. Round down. Round off. Stay the same. 49.226. There we are, my friends. Okay. So in the Google Classroom, these 2 sheets that I've done, and there's even more practice in the Google Classroom that you can try on your own with the answer key attached. Let's take a look at what we did next. Okay, so here we go with the integer rules. So the next thing that we had practiced in class was remembering how to add, subtract, multiply, and divide integers without using a number line and without using a calculator. Okay, so we went through all the rules. We first did adding rules, subtracting rules, then multiplying rules, and then division rules, which are the same as multiplying rules, and practice those using some problems. That eventually will come up.
at some point, like now. But first, let's go back and review the rules. Okay, so it's very important to make sure, you have to make sure that you understand integer rules in order to perform integer operations, because guess what? The basis of algebra is understanding integer rules. You have to understand not only integer rules, but fractions and order of operations and decimals are all things that you need to know, the basic skills you need to know in order just to get through basic algebra. So this is why we have to take it back. So this video series is taking it back to the beginning and making sure we understand these basic operations. Okay, so trying to do dust off that dust from your shoulder again with adding integer rules. And this is how I set it up. There are 3 rules when it comes to adding integers. By the way, positive numbers and negative numbers, those are integers. Okay, so I write it like this. Let's take the first rule. We're all very familiar with this first rule right here. If I have a positive number, right, a positive number plus another positive number, my answer will be positive. I'm just going to add them together. For instance, regular old numbers. A positive 16 plus a positive 4 is going to give me a positive 20. We're all very familiar with that, right? Check. Rule, not bad at all. Everybody gets them. Okay? Here we go. Then we start freaking out people a little bit. What happens when I have a negative number plus another negative number? Here's the deal. A negative plus a negative, our answer is going to be negative. We just add those 2 numbers together. That's right. For instance, a negative 5 plus a negative 8, add them together, which gives me 13, and keep it negative. You know, often in class, you'll hear me say that this is a ghetto version question, or ghetto, what I call it ghetto shopping. It's kind of funny because I think of it this way. I'm like, ghetto shopping? You'll hear me say that a lot, because let's pretend that you have negative 5 in your bank account, and then you went and spent $8 more, right? So that means you owe that much more money to the bank. So you now owe the bank 13. So negative 13. If you have a negative plus another negative, you will never be in the positive. Okay? The answer will always be negative, because basically what it represents is you are digging yourself further and further into a hole in your bank account. So you keep going down. All right? Now, it's this third rule. It's this third rule that trips people up sometimes. What do we do when we have a negative plus a positive, or the other way around, positive plus a negative? Same thing, doesn't matter, right? Okay, even though it's an addition problem, check this now, even though it's an addition problem, we have to find the difference between the 2 numbers. How do we find a difference between the 2 numbers? Subtract them. Subtract them. That's right, even though it's an addition problem, subtract them. So if you have a negative plus a positive, or a positive plus a negative, first thing you want to do is subtract the 2 numbers, okay? So for instance, like the one that I have down here, I'll put it up. I have a negative 9 plus a positive 8, okay? First thing I'm going to do to find the difference is subtract them, right? So if I subtract 9 minus 8, I have 1, don't I? 1. Then the second part says, keep the sign of the larger digit. What digit is larger? Here's the key. Here's the key. When I say the word digit, I am talking about a pictorial representation, right? Not talking about the value of the number. The word digit is a pictorial representation. So when I say digit, I'm meaning just the 9 or just the 8, which is a larger digit. You can see that the 9 is larger, right? So I'm going to keep the sign of the larger digit. If the larger digit is 9, but that 9 happens to be negative, I'm going to keep the sign of the larger digit. This is why I'm taking my time to explain this, okay? Because I do not want to say keep the sign of the larger number, because let's look at it technically. If I say keep the sign of the larger number, right? Which number is larger? A negative 9 or a positive 8? Positive 8 is larger, is a larger number, right? But if I put my answer as a positive 1, that would be incorrect. So instead of saying keep the sign of the larger number, I say keep the sign of the larger digit. So when I say digit, you are solely just focusing on the visual representation of the number, not the value of the number. Okay, so therefore, if I keep the sign of the larger digit, my larger digit is 9. It happens to carry a negative. So there we go. Subtract, keep the sign of the larger digit. All right, let's try another example of those. The other example that I have down here, you see I have 20 plus a negative 5. Again, anytime you have a positive plus a negative or negative plus a positive, we subtract to find the difference, right? 20 minus 5, that's going to give us 15. Which has the larger digit? I have a digit of 20 or a digit of 5. In this case, the 20 is larger, and that 20 happens to be positive, so my answer will stay positive. There you go. Oh, here's something too. Check this out. Let's say, for instance, that it was written like this, okay? I have 5 plus a negative 20. So again, you still have a positive plus a negative or a negative plus a positive, right? So we subtract to find the difference. If these were numbers in which you had to do subtraction by hand because you weren't sure, right? Don't do this in your head. It is okay to put the 20 on top so that you still see that it's 15. All right? To find the difference, make your subtraction make sense. So again, the difference is 15. Keep the sign of the larger digit. I can see my larger digit in this case is negative, because this time, the way I wrote it, the 20 is a larger digit than the 5. So my answer, negative 15. Trying one more example problems for the addition. Let's say that I had negative 7 plus positive 12. Again, positive plus negative or negative plus positive, we subtract. Now, if I'm not really good with my facts and I got to do this on paper, I am not going to do it like this. On my paper, I will write it like this, right? 7, 8, 9, 10, 11, 12. The difference is 5. Keep the sign of the larger digit. What's the larger digit? The 7 or the 12? The 12 is a larger digit. So and that 12 happens to be positive, so I will keep my answer as positive. All right, let's put this to practice by one of the sheets that we did in class. Oh, look at that. Happened to be the same question that I just did as practice. All right, so this time we have negative 12 plus 7. Again, when we have a negative and a positive, we subtract. Keep the sign of the larger digit. So 12 minus 7, 7, 8, 9, 10, 11, 12. Just like we did in practice, we know that this is 5. Which is the larger digit, the 12 or the 7? The 12 is in this case, so my answer is a negative 5. Taking a look at number 2. Here we go. Look at what we have. We have a negative plus a negative. Remember, negative plus negative. Negative plus negative. The answer is going to be negative. Just add them together. Go shopping. So 10 plus 7 is going to give me 17. Keeping it negative because it means I went further into a negative bank account. Here we go with number 3. I have a negative and a positive. Remember, negative and a positive, we first subtract. We subtract. The difference between 12 and 6 is 6. Again, don't forget, I am not doing it like this in my head when I subtract. I'm doing it like this, okay? So I can see the difference easier. Don't make it harder on yourself. All right, so the difference is 6. Is it going to be a positive or negative 6? If I keep the sign of the larger digit, I can see that 12 is a larger digit. And that 12 happens to be positive, so my answer will stay positive. Don't let number 4 fool you. Yeah, we're still talking about integers, but regular numbers are integers. So this is just a positive plus a positive. 8 plus 7, a regular old 15. All right. Now, here we go. Let's take a look at number 7. Skip around a little bit. You have a negative plus a negative. right? Remember, again, ghetto shopping, negative plus negative is negative, just add. Negative plus negative is negative, just add. So 1 plus 46, that gives me 47, negative 47. There it is. All right, so now we have, let's go to number 9. I have negative 34 plus 50. A negative and a positive. Again, we subtract, right? So 50 minus 34. So I can figure out the difference between the two. I'm going to subtract. That gives me 16. Now, is it going to be a positive or a negative 16? Well, keep the sign of the larger digit. That 50 is larger than the 54, and that 50 happens to be positive. So my answer will stay positive. So my answer, positive 16. All right. So once we have a grip on the addition rules, right, the subtraction rules become a lot easier. A second here. There we go. So over here for our subtraction rules, there are 3 rules for subtraction. Rule number 1, change the problem to addition. Rule number 2, change the sign of the second number. If that second number is positive, change it to negative. If that second number is negative, change it to positive. And then rule number 3, follow your addition rules. For example, I put it here below. For example, this example right here, I'll put it over here. I have 15 minus a positive 2, which I'll put like this. Okay? Rule number 1, remember, change it to addition. Rule number 2, change the sign of the second number. That second number is a positive 2. So if I change the sign, it becomes a negative 2, right? Rule number 3, follow the addition rules. What do we do when we have a positive plus a negative? We subtract. So we know that this is 13, and we keep the sign of the higher digit. What's higher? What's a higher digit, 15 or the 2? The 15. And that 15 happens to be positive. So my answer will stay positive. Hey, do you notice something? It's the same thing as a regular problem. 15 minus 2 is 13. We all know that. But it follows the subtraction integer rules. Look at that. Okay? Now, let's do the second example, which looks quite different. What if I had, the second example that I have down there is negative 20 minus negative 15. Let's follow these 3 rules. Step 1, change the problem to addition. Step 2, change the sign of the second number. The second number is a negative 15. If I change the sign, it becomes a positive 15. So now I have negative 20 plus 15. That makes this, right, a negative plus a positive. Step 3, follow the addition rules. What do I do when I have a negative plus a positive? I know I'm going to subtract to find the difference. 20 minus 15 is 20 minus the 15 is 5. Now, is it going to be a positive or negative 5? Well, keep the sign of the larger digit. What's larger, the 20 or the 15? The 20 is a larger digit, and that 20 happens to be negative. So my answer, negative 5. All right, let's put this to work. Here we go. All right, taking a look at number 11. Okay, so number 11, let me write it bigger over here. I have 2 minus negative, oh, that's kind of sloppy, isn't it? I have 2 minus a negative 2. So remember, step 1, change the problem to addition. Bam. Step 2, change the sign of the second number. My second number is a negative 2. I'm now going to change it to a positive 2. Step 3, follow your addition rules. My addition rules say I have a positive plus a positive. I know the addition rules is to add them together, keeping it positive. 4. So notice this answer is a positive 4. Hey, here's a little trick too, and some of you already know this. There is a secret little hack. Whenever you see a combination like this, you see a subtraction sign, you see half a parenthesis sign, and then you see a negative sign, notice it looks like it creates a big old plus sign, doesn't it? So it looks like this. See that hack? We'll run into that again and again, and I'll show you every time that we see it. Let's take a look at number 12. All right, number 12. I'm going to rewrite it over here. I have negative 1 minus 10 for subtraction. Step 1, change it to addition. Step 2, change the sign of the second digit. That's a positive 10 now. So if I change the sign, it's now going to be a negative 10. Okay? So that means I have a negative plus a negative. Remember the rule, negative plus negative, that rule right here, it means I'm going to just add them, keeping it negative. So I have this is going to be negative 11, just add, keeping it negative. All right, let's go to the next one. Now, again, when you go in algebra, you should start thinking as every number is integers. You can see this as a regular 8 minus 7. I know that you know that 8 minus 7 is just 1, which is correct. But if you have your algebra brain cap on, right? Let me write over here. Let me show you what it looks like by following the subtraction rules. Watch this. Step 1, change it to addition. Step 2, change the sign of the second number. That's a positive 7. I change it to a negative 7. And remember, step 3, I follow the addition rules. I have a positive plus a negative. What do we do when we have positive plus a negative? We subtract. 8 minus 7, 1. Keep the sign of the higher digit. What's higher, the 8 or the 7? The 8. And that 8 happens to be positive. So my answer remains positive. So remember, even with regular old subtraction problems, right, you're still applying the subtraction integer rules. You know that a regular old 8 minus 7 is going to be 1. Even following the subtraction rules for integers, you're still going to end up with 1. So some of them are very, very easy to see. Okay? Let's take a look at what number 14 tells us. Number 14, I have negative 8 minus negative 6. Here we go. All right. Step 1, change it to addition. Step 2, change the sign of the second number. That's a negative 6, the second number. If I change the sign, it becomes a positive 6. Step 3, follow the rules of addition. That means I have negative plus a positive. What do we do when we have a negative plus a positive? We subtract. Find the difference. 8 minus 6 is 2, right? Keep the sign of the higher digit. What digit is higher, 8 or 6? 8 is higher. That 8 happens to be negative. So I will keep the sign. Answer, negative 2. Here's where that hack is. Watch the hack. Watch the hack. Remember the hack? Anytime you see a combination of a subtraction, half a parentheses, and a negative sign, it creates an addition sign. So I can really look at this as just negative 8 plus 6. You see it now? I just did a shortcut instead of saying step 1, step 2. Okay? And we know that this, following the addition integer rules, is going to be a negative 2. There's that hack. Ta-da! All right. So, let's do a few more. All right. 11 minus 4. Again, if you look at it, you can see that this is going to be a positive number because this is a regular old subtraction problem, right? We know that 11 minus 4 is 7, okay? We know that this answer, just by looking at it, is going to be 7. But let's go ahead and follow the subtraction rules anyway. I have 11 minus 4 following the subtraction integer rules. Step 1, change to addition. Step 2, change the sign of your second number. If it's a positive 4, it's now negative 4. Step 3, follow my addition rules. I have a positive plus a negative. What do we do when we have a positive plus a negative? We subtract. 11 minus 4, guess what? 7. Keep the sign of the higher digit. What's higher? The 11 or the 4. The 11 is higher, and it happens to be positive. So again, positive 7. Just like the regular subtraction problem would be. All right, let's try another. All right, looking at number 16. 48 minus negative 31. Here it is. Okay, step 1, change it to addition. Step 2, change the sign of the second number. That's a negative 31. So I will now make it positive 31. Step 3, follow your addition rules. I have a positive plus a positive. Regular old addition problem. So my positive plus a positive. 48 plus 31, that's going to give me a positive 79. Did you see it? Did you see the hack that's right there in the middle of it? Look at this. All right, 48 minus negative 31. You see the hack? You have a subtraction, half a parentheses, a negative sign, basically creating a big old plus sign. So if I'm looking at it, I see a positive 48 and a positive 31, right? That just was the other end of the parentheses. So I can tell automatically, I just did skip the steps, that's all. You see it as positive 79. All right, taking a look at number 17. So number 17, 18 minus 41. Step 1, change it to addition. Step 2, change the sign of the second number. Step 3, follow your addition rules. I have a positive 18 plus a negative 41. What do we do with a positive and negative? We subtract. Keep the sign of the higher digit. All right, so basically, remember I'm doing my subtraction like this. 41 minus the 18, that's going to give me 23. Right? Here, 8, 9, 10, 11. Yep, 23. So that's 23. Okay. Now, don't forget, keep the sign of the larger digit. What digit is larger? The 18 or the 41? The 41 is larger, and the 41 happens to be negative. So my answer will be negative. Negative 23. All right. Now, let's do 2 more. Here we go. This time, number 19, I have negative 1 minus negative 3. Okay. Remember, step 1, change it to addition. Step 2, change the sign of the second digit. That second digit is a negative 3. So I will change it to make it look like a positive 3. Step 3, follow your addition rules. Follow my addition rules. I have a negative plus a positive. What do I do when I have a negative plus a positive? We subtract, find a difference. The difference between 1 and 3 is 2. Keep the sign of the larger digit. What's larger? A negative 1? A 1, remember, follow the digit. Or 3. The 3 is a larger digit. That 3 happens to be positive, so my answer stays positive. Oh look, the hack was there too. Watch this. You see the combo, minus, half a parentheses, minus, it creates a plus sign. Therefore, changing it to an addition problem for you already. And we can see that we have a negative and a positive, right? So negative plus a positive. We can already see it without having to go through step 1, step 2, step 3, right? And so that we know we're going to subtract. We know we're going to keep the sign of the higher digit. So the hack basically just cuts down from going from step 1 and step 2. So knowing that, look at number 20. Let's just do it from the hack. We see the hack. Here, here, here. Creates a plus sign. So basically what I'm looking at is a negative 1 plus a positive 40. Right? So looking at negative 1 plus a positive 40. Okay? You know we're going to subtract because we have negative and a positive, keeping the sign of the higher digit. What digit is the higher, the 1 or the 40? The 40 is. And remember, that represented a positive 40. So my answer, 39. There it is. All right, my friends. Now, we practiced adding and subtracting. Let's go to multiplying and dividing. So here's the thing. This is way easier, right? multiplying and dividing integers are way easier than adding and subtracting rules. 3 rules for multiplying and dividing. They share the same rules, okay? So multiplying and dividing have the same rules. When I have a positive times a positive, or I could say a positive divided by a positive, my answer is positive. For example, we all know positive 8 times a positive 2 gives me a positive 16. Okay? So a positive times a positive positive, or positive divided by a positive will also give you a positive. When we have a negative times a negative, your answer is also positive. Remember that answer is also positive. For example, negative 2 times a negative 5, my answer is a positive 10. Same thing if I were to do division. A negative divided by a negative is positive. The only time we end up with a negative answer is when we're mixing them, such as a negative times a positive or positive times a negative. For example, negative 7 times a positive 3, that's a negative 21. Or positive 4 times a negative 6, that's a negative 24. So again, if you're multiplying a positive with a positive, your answer is positive. If you're multiplying a negative times a negative, your answer is positive. Anytime you're mixing the two, the answer will be negative. Same thing that follows with division. Anytime you're dividing a positive with a positive, your answer is positive. Anytime you're dividing a negative by a negative, your answer is negative. Anytime you're dividing, mixing the two, a positive and a negative, your answer will be negative. Let's quickly put that into practice. Here we go. Alrighty. Oh, those were more of the adding practice. So in the classroom that I provided you some more of the adding subtracting integer practice sheets that are like this. Same thing, just higher numbers, just a little bit of a higher numbers that you can see. And answer key is attached for you to practice some of those on your own. This video is already over like an hour long, so I'm going to skip over doing parts of that in a video, but we'll review again in class. So let's go ahead and practice with the multiplying integer rules. Here we go, quickly doing these. All right, so now I have our first problem. I have 6 times negative 4. Remember, we have a, here we go, a positive times a negative, right? Our answer is going to be negative. 6 times negative 4, that's a negative 24. Over to number 2. You have a positive times a positive. You know your answer is going to be positive. Just multiply. 4 times 2, 8. Taking a look at number, skip around here. Taking a look at number 8. You have a negative times a negative, right? Negative times a negative. Your answer is positive. Just multiply the numbers. 2 times 1, 2. Same thing with here. Negative times a negative. Your answer is positive. Just multiply the numbers. 8 times 2, 16. Let's take a look at number 11. You have a negative times a positive. Anytime we're mixing the two numbers, your answer is going to be negative. Just multiply. So for here, 7 times 5, negative 35. There we go. So, and then let's practice. Whoops, I left this from the classwork that we done last time. Let's get a little bit more complex with these by doing 3 digits at a time. Let's first take a look at number 18. I'm going to rewrite it over here. I have negative 6 times negative 10 times negative 8. Okay, we're going to take these 2 numbers at a time. Okay, so first I'm going to do is negative 6 times negative 10. Remember, we have a negative times a negative here. Negative 6, right, times negative 10. Remember, when you have a negative times a negative, that's positive. 6 times 10, that's 60. 60. So far I have 60. I bring down the rest. I have 60 times negative 8. So 60 times negative 8. So this time I'm doing a positive times a negative. Okay? If I have positive times a negative, remember my answer is going to be negative. And then when I multiply 60 times 8, I get 480. There we go, 480. So negative 480. Now, Again, if you're doing these integer rules, it is going to be part of the integer rule practice like this on a GED test. It's going to be part of practice number 1 or part number 1 on the GED test, in which you cannot use a calculator. So you got to make sure that you can practice your multiplication without a calculator. Okay, let's try another one. Here we go. All right, so taking a look at number 20. Number 20, I have 6 times 6. That is so sloppy. 6 times 6 times negative 2. First doing these, excuse me, went a little far now. Doing this, you have positive 6 times positive 6. That's a positive 36. I bring down the rest. I have 36 times a negative 2, right? So 6 times 36 times a negative 2. That is a positive times a negative. I know my answer is going to be negative. And then I will multiply 36 times 2. I'm going to get 72. So final answer, negative 72. Let's do one more. Taking a look at number 21. Okay, so I have number 21 says negative 5 times negative 4 times negative 10. Here we go. Okay, so first thing I have is negative 5 times negative 4. Well, a negative times a negative is a positive. 5 times 4 is 20. So far I got positive 20. I bring down the rest. I have 20 times negative 10. Positive times negative, I know my answer is negative. 20 times 10, 200. Final answer for that, 200. All right. So remember, division rules are absolutely the same. All right. So taking a look at some of these are easy division problems. Again, just practicing the rules that we have. I have 35 divided by negative 5. Again, you have a positive divided by a negative. Anytime you have a positive divided by a negative, the answer will be negative, right? 35 divided by 5 is negative 7. Okay? Now, again, you should be able to do these without a calculator, which reminds me, I might have to do some videos with long division practice. I'll ask you guys in class. We'll do some long division practice to see if we need to go there. Let's take a look at number 4. Look at number 4. With number 4, I have a negative divided by a negative. What happens when we have a negative divided by a negative? Our answer will be positive. 8 divided by 2 is 4. So leaving it as a positive 4. Okay. And looking at number 6, we have a negative divided by a positive. We know the answer is negative. 24 divided by 8. 8 will go into 24 3 times, leaving us an answer of negative 3. All right. Let's take a look at these. Please, please, please remember that fractions mean division. Yay! So whenever you see problems that look like this, it's the same thing. It's still division, right? Taking a look at number 19. All right. Negative 105 divided by 7, right? First, we know our answer is going to be negative because we have a negative divided by a positive. That fraction is the same thing as saying this, 7 and 105. It's saying the same exact thing. 7 will go into 105, I will tell you, 15 times. In fact, I'm going to do this one out by hand, just so you can see a practice of a long division practice right here. And if we need more practice of long division, like I said, I'm going to ask you guys in class if we should practice some long division by hand, because you certainly will need to know that for the test. So let's do that. 7 and 105. Now, I like to do every place value when I divide, meaning this. I take it one number at a time. 7, will it go into 1? No. 7, will it go into 10? Yes. How many times will 7 go into 10? One time. And then I take that 1, right? I multiply it with the 7. 7 times 1, 7. I subtract. 10 minus 7, 3. I bring down my 5. Oh yes, dust off the dust. 7 will go into 35 5 times. Put my 5 up here, because 5 times 7 is 35. Subtract, leaving me with 0. So again, my answer, 15. But remember, it was negative 15 because a negative divided by a positive is negative. Just wanted to put that one up there to show an example of the division by hand, just in case we needed to review. Let's take a look at number 20. You have a negative divided by a negative. Negative by negative, you know your answer is going to be positive. This is basically saying 4 divided by 1. So this answer 4. 4 will go into its 1 will go into 4 times. All right. 21. Negative divided by a negative. Your answer is positive. 10 divided by 2. How many times will 10 go into 2? Or 2 will go into 10. Answer 5. 22. You have a negative and a positive. You know your answer is going to be negative. How many times will 12 go into 144? It will go in 12 times. And there we go. All right. So I'm going to leave it for here. Remember, in the Google Classroom, the whole sheet is here with the answer key. All right. And then I think what I'll do is probably as part of a warm-up question or two, or maybe integer practice. Oh, wait a minute. Let me explain this. I got to explain this first before I go. This page is a picture I took from the GED book I told you that I said was a good practice here with some of these questions, right? I think these are a great practice to go through. And let's see. Oh, I didn't mean to do that. All right, so I think I'm gonna leave it here because, like I said, this video is over an hour long. And so for the warm-up part of the warm-up that we'll see next week, we'll do some of these. And so therefore, they will be on the next video. Okay, guys, I'm going to leave it here for now. And I will see you at the next class. See ya.